So let me introduce Ted Hill, our Rage Operations Manager. Ted, come on up on stage.
I'm going to pretend that we've had a tragic accident in our plant, and this device is going to lose power, and then it's going to have a tragic incident on the plant floor.
Good morning. My name's Ted Hill, and this morning I get to be your host as the demo team shows you some of our new products and capabilities. I think that makes this a TED Talk. We had a lot of fun last year doing the demo. This is the thin client. I thought I smashed it. Watching that video, it looks like I crushed it. It works just fine. It had a scratch, dent, little duct tape, good to go. During the demo today, we hope to entertain you, at least a little. But more importantly, we hope that you learn something about the new products that we've been working on that makes you want to learn more about them this week at TechEd. Frank mentioned that we've been busy over the last year adding breadth and depth to our analytics portfolio. He's right. We're going to be showing you FactoryTalk Analytics Edge, Dataflow ML, DataView, and a product based on a technology that internally we call Sherlock. Earlier, Blake introduced Jim Heppelman from PTC. We'll also be showing you how Rockwell and PTC products work together to help you create your connected enterprise. Jim and the rest of the team from PTC, welcome to TechEd, and thanks for your help this week. It's an exciting time in automation and information. During our careers, change has never happened at a faster rate. It's a ton of fun to be part of, and I'm sure that it is for all of you too. Our challenge as automation engineers is to solve problems by thinking differently. As we learn more about what's possible in automation today, we have the opportunity to deliver new value to our customers. Our goal remains the same. Provide automation and information systems that maximize industrial productivity while ensuring a safe environment in our plants. Blake mentioned that there's been a 120% increase in industrial productivity over the last 30 years. Analysts expect a lot more as the analytics Frank spoke about are broadly applied in manufacturing. Think of the changes that we've been part of over our careers. Did you start working before email? I did. Did you ever have a CompuServe account? Do you remember when out of the office meant the same thing as not available? No cell phone, no conference calls, no Skype, no email? Did you ever have a pager? Did you call it a beeper? Do you remember your first cell phone? It's likely the mid-90s. Mine was a Nokia 6160. I remember it well. Did you ever have one of these? BlackBerry. Did your spouse find it annoying when you kept checking it during dinner? We had no idea what was ahead and what connected would really mean in our work lives. That change has happened over the last 25 years. During that same period, we've deployed multiple generations of products into our plants. Many are still in use today. Our challenge? As automation engineers, we're expected to deliver increasing value from our automation systems, deeper integration with IT, analytics on performance at a machine, line, and plant level, predictions on when critical equipment will fail. We have to do this with the generation of products that are already deployed in our plant and integrate them safely and securely with new products that are coming out today. Our cell phones have changed a lot, and so have the needs of our automation systems. This morning, we're introducing Rage, the Rockwell Automation Global Energy Drink. I wanted to call it Rage 5000, I admit. I got overruled by management. We're going to show you this morning how at Rage we're using the latest products from Rockwell Automation to solve problems by thinking differently, to create smart machines and equipment, to provide analytics on our operations at our machines, across our lines, and across our enterprise. Rage is global. We have 319 plants in 73 countries around the world. We're everywhere: London, Paris, Kwambinambi, New York. We've had our fastest growth ever in emerging markets over the last quarter. Our CEO, she just announced plans to open 23 more manufacturing plants over the next year. My team calls it the 12-month march. We have the challenge that everyone wants: growth. Let's take a closer look at one of our lines here in San Diego. On my right, we have our mixing system. It's comprised of several pumps and an agitator. They're all controlled by PowerFlex drives. It has a full assortment of instruments from E&H, flow transmitters, temperature sensors, all sorts of stuff. Everything's attached to a Logix controller, and there's a panel view 5310 for the operator to interact with. We couldn't bring the bottling line with us, wouldn't fit. It's here in the middle of the stage. The last step in our manufacturing process, it's the packaging area. It's here on my left. It's state-of-the-art. This is a very special machine, and we'll be showing you later what makes it really smart. Just like at your company, at Rage, our success starts with the talented automation engineers that make everything happen. And we have a standout team. Jonathan's the driving force behind several of the analytics products we use at Rage. He joined Rage after spending time with both Microsoft and Amazon. Julie knows a lot about making things. She spent the first decade of her career working at a pharmaceutical company. She joined Rage in our solutions business, and today is the business manager for design software. At Rage, service is important, and that's Sherman's role. He comes to it pretty naturally, having been part of the team at Rockwell Automation that expanded their managed services offering. Like all lasting relationships, I first met Andrew in a bar more than 30 years ago. I was a first-year engineering student, a frosh. Andrew was much older. He was one of the engineers tasked with teaching the frosh what being an engineer really meant. He helped me then. He's been helping me ever since. So how do we tell our story about Rage? Well, good story's got three elements. It's got to have a villain. It's got to have a hero. It's got to have suspense. A villain? We'll find one. A hero? That's easy. That's the Rage Automation team. And suspense? We're a tech ed. This is live. It's plenty of suspense for me. Our story this morning, it's really about our other coworker, Thomas Rouble. We call him T. Rouble for short. Thomas has worked at Rage for 40 years. He joined before the PLC-5, the PLC-3, or even the PLC-2. Gas was 63 cents a gallon. Saturday Night Fever just come out. Happy Days, The Love Boat, Charlie's Angels, all must-watch TV. Thomas is just like someone where you work. He knows the right way to do things, how they've always been done. He's always helping, always has the best of intentions. He's not the kind of guy you find on LinkedIn. At Rage, we're not sure what his real job is. He isn't a villain in the classic Hollywood sense, but mayhem follows Thomas around. No doubt, he'll find a way to help us this morning. What could go wrong? We're going to start our story today at the overview that the team uses to ensure that we're focusing on issues before they impact production. It's available to anyone on any device through a browser. Now, our process probably seems pretty simple, but we push our plants hard. And there's a fine line between operating at peak capacity and pushing our equipment past its limit. Andrew, why don't you explain what we're looking at on our overview screen?
1 second, Ted. Got a little energy to get me going this morning.
Good.
Delicious. Let me just get our system ready. Well, look, at Rage, we are a global manufacturer, and we needed a solution that enables our staff to get the information from anywhere, at any time, on any device. So we developed a solution in the cloud using Microsoft Azure. This system allows us to combine various data sources and provides us the visualization and analytics capabilities that our users need. Let's take a look. So I'm using the PTC ThingWorx visualization tool, and I've navigated to the Asset Advisor page where I can see both my lines in San Diego. I see line 1 and line 2. Here I see that both lines have dual mixers that feed a filling machine that ultimately go to a packaging machine. Now here right away I can see that mixer 1 is red, and I have a device health status of bad. Like any good analytic, I need to take some action to close the loop. I'm going to call a friend. Hey, Jonathan. Morning. Hey, I'm looking at the site overview for line 1, and mixer 1 is faulted, and I've got a device health fault on the analytics. I'm not sure if these things are related. Think you can take a look for me?
Yeah, let me take a look. I'm going to open FactoryTalk Analytics for devices. We just call it our Shelby. Shelby is an analytic appliance that sits on our network looking for faults and trying to find details about the problems it finds. I'm going to start with the Action Deck view. This is an exception-only interface that shows me the things Shelby knows I'm interested in. This is just the problems. I'm going to filter by the mixer, and I can see there's some issues there. So I'm going to click on it to get a little more detail. This is the dashboard for the mixer that Shelby automatically built. Every time it encounters a device, it builds one of these displays and tries to surface details about problems it finds. In this case, I can see that there's an electronic overload trip, the fault code is F7, and the type is 1. I don't have a user manual handy, so I'm just going to ask Shelby for some help. What does fault code F7 type 1 on a PowerFlex 40 means? There's an excessive motor load, so the drive is probably tripping to protect the motor. This is something that wouldn't clear up normally on its own. Has someone been resetting the equipment? Thanks a lot, Trouble. Maybe instead of just clearing these faults, we should try to find the root cause. But this is a pretty complex machine, and I don't want to take it down for maintenance until I know where to look. Fortunately, PTC has provided me with an augmented reality view of this machine. So I can start my investigation with a 3D model. I'm going to start by placing the model in real space. Zoom in a little here so I can get a closer look. I'm going to spin it around. There's the motor, so this must be the drive. Andrew, I think this is where we should start our investigation.
Hey, that's pretty cool. I can really see how AR and integrating with our analytics is a powerful combination. But I got to ask, how hard was that really to integrate those two pieces together?
It's actually really easy. The modern REST APIs and FactoryTalk Analytics make it simple to pass the data it finds up into other systems like ThingWorx.
It reminds me, our power consumption on the mixer has a strong correlation with product quality. Wouldn't it be great if we could compare actual power consumption with predicted power consumption?
What do you mean?
Well, we already measure our actual power consumption when we're running batches using our power monitors. But would it be better to have some sort of power reference so we'd know if we're doing a good job? Then a comparison could help us find the right settings for each mix. What do you think?
Yeah, I see what you're after. I'll bet that's something we could do with our new Sherlock module. Project Sherlock is a new analytics add-on for control logics that watches data produced by a control operation and uses an artificial intelligence to predict values and detect anomalies. With its unique physics-based approach, the Sherlock AI is particularly well-suited for manufacturing problems. I'm going to start by adding the module to my ControlLogix chassis. And I'll connect the Ethernet cable directly to my PC. And just like Shelby, I'm going to use a web-based interface to configure my analysis. I'm going to create a new prediction for our mixer using the application running in controller slot 0. I'm going to predict power. Sherlock needs to know what tags to look at, so I'm going to tell it about my mixer. And it wants to know, to start, what is the thing that I'm trying to predict. So I'm going to give it power and give it the normal bounds of operation. This is a heavy-duty mixer. And then I'm going to give it any variable that I think might be related to our power. I can cast a wide net here. Sherlock's smart enough to figure out what really matters on its own through observation. So I'll give it speed and I'll give it torque. The other thing that might be useful is understanding what product we're producing. Because the physics of each of our products is slightly different as it's being mixed, Sherlock's smart enough to create a different model for each of those different products. After I confirm my settings here, I can return to this detail page and save an L5X. This is a code block that contains a UDT that Sherlock uses for its predictions. I can import that UDT into my control program, and that will add the tag that Sherlock writes to. It won't touch any other tag in the controller, but it will observe them and write its predictions into this type. There'll be a brief training period that we're going to fast forward through here today. During this training period, Sherlock is watching the application, learning from it, cleansing the data, and building and testing models until it finds one that can predict the process. When it's done, I'll have a tag here that contains Sherlock's prediction that I can monitor in real time. We chose to implement this on our HMI so I can see the predicted versus actual at an operator level display. But we could also use this value in our control logic if we want to tune the process. We can historize the value for analysis later, or we can pass it up to display like in ThingWorks so we can see this at our overview screen. Now that we have data flowing from FactoryTalk Analytics for devices, monitoring the parts of the machine, and we have Sherlock and AI monitoring the actual application, this has become a pretty smart machine. But I'll bet there's more that we can do. Hey, Julie, weren't you telling me about a new condition monitoring system we've been learning about?
I sure was, Jonathan. Did you know the way we used to do predictive maintenance was to physically walk around each piece of equipment once a month? My friend Rouble, he's actually a vibration expert. He'll walk up to the machine, which isn't always this easy to get to. He'll take measurements all over the machine, and then need to use some really complex software to study the vibration. He'll look at each signal. He'll do some crazy math, like fast Fourier transforms, to figure out every which way the machine is vibrating, and then try to figure out what it is that's causing it to shake at those frequencies. But even after all that, we still might have failures now and then if one happens in between his monthly survey.
Julie, would you really be able to look at that and predict a problem with a machine or know when to do maintenance?
No, there's no way. But the good news is, with Dynamics, we have a much simpler way of doing these things today. Integrated condition monitoring takes the complexity of vibration monitoring that in the past required a very specialized skill set and turns that into simple tags, integrated into logics, and visualized on the HMI. In doing this, I can combine the power of vibration analytics with the process expertise that I have and choose what action to take if something happens with the equipment. So Rouble, now that you don't need to do those surveys anymore, you can focus on some other productivity projects I have in mind. So Jonathan, like Project Sherlock, Dynamics is a system-level analytic, but this is built specifically for rotating and reciprocating equipment. It can do a lot for us. It can protect our high-value processes and equipment, resulting in more consistent quality and predictable maintenance. This is a big deal because Ted keeps reminding me that this line is critical, and if any part of it has a problem, we need to know about it now. So for the pump here on mixer 1, I want dynamics to tell me what's going on. Is it running okay? And if something is going to go wrong, it will alert me so that I can deal with it. I can adjust process parameters to stop cavitation or turbulence. Or if it's mechanical related, I can plan maintenance. Or if it's an electrical fault, I can schedule time to swap out the motor. But bottom line, whatever it is, I can deal with it before it shuts us down. So let's take a look at those tags in Logix Designer. So as you can see here, condition monitoring tags provide the status of the overall alarm state. If I look at this tag, I can see right now I'm at an elevated level. So I want to make sure this equipment doesn't get destroyed. So I'm going to create an alarm associated with this level. So let's take a minute and talk about a new Logix alarm mechanism we call tag-based alarms. This new mechanism really sets the bar for simplicity when creating and deploying alarms. I can simply right-click on the tag. I'm going to say Add Alarm. I'm going to type in a description. And then I'm going to set the condition to high. I'm going to type in a message. And click OK. And then I'm going to go over here to my alarms. And I'm going to click this checkbox to say Use it. And that's all there is to it. And once created, this alarm will now automatically propagate to my PanelView 5310 with no extra configuration required. There you go. Now that's simplification. And they're not just easier to configure, they consume considerably less memory, and they don't impact my performance at all, even if I get a burst of several alarms. So Ted, as you can see, the analytic capabilities of Dynamics and the simplification of the new tag-based alarm capabilities integrated with PanelView 5310 have significantly improved the intelligence of this machine.
Thanks, Julie. That's pretty exciting stuff. I want to highlight a couple of the things that Jonathan and Julie showed. Blake and Frank both spoke about the value of simplification. The team at Rage showed several examples of analytics where simplification came from the integration into the architecture. It puts the power of the analytic in the hands of the automation engineer. It makes it useful to them. What action should be taken? What should be done with operations? What does the operator need to know? How quickly should the system respond? Jonathan started troubleshooting our problems on the mixer by leveraging device analytics. He added predictive analytics, so now the system's configured to predict power consumption. Julie added condition monitoring to the mixing system, so now we've got information on the mechanical state of the equipment that she can easily incorporate into her control strategy. She also configured Logix tag-based alarms. When Julie decided that she wanted to provide additional information to the operator, all she had to do was make a simple configuration change in Logix, and she was done. She didn't do anything else. She didn't configure communications. She didn't create an alarm in the HMI. She didn't download a new application of the panel. The team was able to take the mixing system, pretty typical controls, and make it smarter by adding several layers of system-level analytics. By thinking differently, the Rage team created a smarter machine. Now, this additional information on the performance of the mixing system, it can be used by our higher-level analytics to compare the performance of our mixing system here in San Diego with our other systems around the world. More on that later. When Blake spoke, he talked about how much manufacturing has changed during his career, what our industry saw coming, what we didn't. Security. Security is impacting us in ways that even 10 years ago we didn't foresee. If our OT systems were all new, addressing security would be fairly easy. They aren't. IT-OT convergence has come with risks. The risk is compounded by the fact that OT systems haven't been upgraded and maintained with the same diligence as IT systems. They didn't need to be. That's no longer true. It can't be. Subversive activity could be an issue. But the bigger risk is likely something happening by accident. Someone needing to do something quickly. Someone using a portable on the OT network that hasn't been fully patched and updated. Someone using a USB drive to quickly copy a file off a computer on the plant floor. Someone making a change to get production up and running again. Someone's actions can inadvertently have real consequences. I'm sure you all remember the WannaCry attack from last spring. It impacted manufacturing companies around the world. What would you have done if your company had been infected? How long would have it taken you to get your systems up and running again? Could you? At Rage, Sherman's responsible for our infrastructure. The more I've learned about what has happened at other companies, the more I worry about what can happen here, and the less I sleep at night. Let's find out from Sherman why he looks so well rested. Sherman, welcome.
I'll tell you, peace of mind really helps me sleep at night, and Rockwell Automation services have played a big part in that. Let me tell you how we got here. I spent time with their network services team assessing and identifying what assets we had on our network and the risk associated with them. We installed a modern network infrastructure with Stratix managed switches and 5950 security appliances. They allow us to control traffic to our most critical assets. My team spent time with Julie's team, ensuring that we had a robust patching and firmware upgrade plan put in place. Because we don't have resources to monitor our infrastructure 24/7, we have Rockwell Automation actively monitoring and managing our network infrastructure and cybersecurity. They use the software from Clarity, a company that specializes in real-time monitoring of threats and anomalies on industrial control systems. And most importantly, if, or should I say when we have a problem, our applications are backed up in Asset Center, and we have images on our industrial data center backed up. And most importantly, we have a response and recovery plan. So if there's any trouble that happens, we know how to take it. Ted, I sleep well because we're prepared.
What is happening, Sherman?
Hold on. Right on time. Hello? Angela. Hey, what happened? You're taking care of it, right? Wonderful. Thank you.
What was that?
It was Rockwell Automation. They were letting me know that we had a ransomware attack, but they've already begun remediation.
That was really fast. How did they do that?
Well, they averaged about a 2.5-minute response time.
What did they actually do?
We can take a look and see. We'll start by looking at FactoryTalk Network Manager. It's a great tool because it allows my team to view network topology, switch level alarms, and switch configs. This tool was made for my team because they have a strong manufacturing background, but they haven't been trained in IT tools.
Let's see what Rouble did.
Let's take a look. So first I'll navigate to our topology view. This is great because it gives our team a view of what's on the network, and it's automatically populated based off of the assets that it finds on the network. So it looks here, there's a problem with one of our switches. Yeah, this is the switch on the packaging machine. So we'll dive a little bit deeper, see what's going on here. So this next view is great because it gives us all of our switch level alerts and alarms, and it looks like there's been a change to one of the switch configs. So we'll dive a little bit deeper into that. So this next screen gives us just a little bit of detail on the specific alert, but what we really want to see is what's happening on the specific switch that's changed. So let's dive into that. Now this screen is great because it gives us a view into our network, our switch health and performance and status. Rockwell let me know that they shut down one of the programming ports. This is the one that we have designated as our program port. And as you can see here, that port is now shut. That was the port that was attempting to propagate the ransomware.
So how was Rockwell able to detect what Rouble was doing so quickly?
So remember, Rockwell has resources monitoring our network 24/7. And they use a tool by a company, Clarity, that allows them to detect these anomalies when they happen, and they have a robust incident response plan to take action as soon as they see those. Let's take a look. So here's Clarity. In the center, you can see it has gone out and automatically looked at what assets we have on our network, but it's also looked at the traffic that those assets generate and baseline that traffic. This is great because, well, it can look for any changes in traffic patterns, any anomalies, any new assets that are coming on the network, and any bad behavior that's happening from those assets, right? On the left-hand side, you'll see the alerts and alarms that are being generated. These are the alerts that Rockwell sees and that they take action. Let's dive a little bit deeper. So this screen is great because it shows detail on the specific alert and alarm, right? This in particular was Rouble's laptop attempting to propagate malware to our packaging HMI. They took action, shut the port down. Our next steps are to get Rouble's laptop to IT, get it wiped, and maybe we'll let him bring it back on the network.
Let me know if IT wants to borrow my hammer. Sherman, thanks. I really see the value to Rage of having Rockwell monitor our network 24/7. I know you and your team have to sleep, and our production lines can't stop. Sherman emphasized the importance of having a plan, having modern network infrastructure, and ensuring that we're running the current versions of firmware and software. At Rage, that's been hard. Lifecycle management's a real challenge. Tracking the changes that are made into our different systems, even knowing what automation assets we actually have, finding the time to update our software and firmware. Even during shutdowns, our production and maintenance teams, they need the equipment to be operational. At Rage, we're continuously making changes to increase capacity, support new products. You get the idea. Julie's responsible for all of the automation systems at Rage. She has dozens of control programs to manage, hundreds of devices that are all networked together. They all control firmware. How does she manage them? How does she monitor the changes that her team makes to support the needs of production? How does she ensure that we're running the current version of software and firmware? Julie, how do you do it?
Well, Ted, I'm glad you asked. We've really focused on modernizing the architecture in the last year. One thing we've implemented is Thin Manager to centralize management of our HMIs. It's so much simpler to manage all the applications because they all run on the server. And using Thin clients, I can customize how our operators interact with the equipment. And not only that, I get a ton of time back because I'm no longer patching every single workstation. Some of the other new capabilities that have really made my life easier when trying to manage all this equipment is FactoryTalk Asset Center. This is the asset management software that I'm using for all of the control assets in the plant. One of the best things I've done is set up disaster backup and compare reports that notify me when changes are made. So if I look here at my PC, I can see the compare report summary. And so if I scroll down here, I can see what changes were made. And so I can get a graphical interface to see exactly what changes were done. And then I can look at my log results, and I can see that Rouble was actually the one that was making the changes. So now I can see exactly what was done. So since these changes have caused our productivity to drop, I'm going to revert back to the last backup before he got in there and started messing with the code. The other really nice feature is I can now see the lifecycle status of all of my assets. And this really helps me plan ahead and budget for modernizations. In the past, we would find out the hard way when something had been discontinued. So then we're in an all-out scramble mode, scouring the spare parts grid looking for a replacement. And let's face it, I probably received a notification about it at some point, but then got distracted by some other fire drill before I could really think through how this impacts my plant. I really like having the information right there in front of me in Asset Center. So one other thing that saves me a lot of time is having one place to go for firmware and software downloads. I've subscribed to notifications on the Rockwell Automation Product Compatibility and Download Center so that I can see when firmware updates are posted. This allows me to make sure that we're on the most current version of software and firmware and try to keep Sherman happy. So I just received an email from PCDC telling me that the firmware updates are available for our devices. So as soon as I get some time, Ted, I'm going to update those assets on line 1 so that we make sure we're up to date.
Julie, the last time you did that, you took the plant down for an entire weekend as you updated the firmware on all your devices. We're ramping up for the holiday. It's not a great time to have production down. How much time are you going to need?
It's okay. It's way simpler now. So we can do that much easily now with Control Flash Plus. I can download the firmware from PCDC, then use Control Flash Plus to update all the devices on the line in one single operation. Then I can update my favorites list. So I can update my favorites list so that this firmware is available when I get some time over on line 2. I can push the same firmware over there, and we're good to go.
Thanks, Julie. It looks like you've got everything under control with our systems. Thanks. Well, I've been talking with Julie about lifecycle management. Andrew has been monitoring our packaging system. It's one of the newest pieces of equipment we have at Rage, and it's a really smart machine. The first thing you'll notice about this machine is it's built around Rockwell's independent moving cart technology. It's increased our throughput. These carts are really fast. They can move up to 2 meters a second. But just as important, independent cart technology has given us a lot of flexibility in how this packaging machine works, allowing it to quickly adapt to changing requirements. Each cart or carriage is controlled separately by logics, allowing the machine to make smart decisions, including when it detects that something's wrong. This machine's kitted out with some pretty sophisticated analytics. It allows the machine to do something that we call completeness checking of the finished product. This machine won't ship a bad package. There's a sensor here that looks down on each cart as it goes by. It's an ODOS imaging 3D sensor. It's a new technology from Rockwell. The sensor looks at the cart as it goes by, and it creates something called a point cloud. The point clouds pass to the compute module that's running in the Logix chassis. That's where the 3D analytics run. Each cart also has a barcode on it, so the Logix controller knows what package is supposed to be on that cart, and it passes it to the compute module. The 3D analytics on the point cloud determines what's actually on the cart and passes information across the backplane back to the controller to tell it whether it's good or bad. So let me try to screw up the packaging machine. So I'm going to take off one of our packages, and the machine will detect that that cart doesn't match what Logix expects it to have on it, and then it will automatically reroute this cart for rework, making it a very special machine. The ability to do completeness checking on the machine itself really shows the value to Rage of the scalable analytics and the scalable compute that Frank spoke about earlier. As you've seen this morning, the systems we use at Rage, they generate a ton of information. I'd like to show you how we've aggregated all of this data together in order to do enterprise-level analytics. How does the performance of our line here in San Diego compare to other facilities around the world? Are other production lines seeing similar challenges that we had on our mixer earlier? How does our energy consumption compare? At Rage, we do a lot of analysis to ensure that we're continuously improving, that we're taking advantage of what we learn at every site around the world. Andrew, how have we integrated all of these systems together?
Thanks, Ted. We've integrated the PTC ThingWorx platform along with our FactoryTalk analytics platform to develop a solution that enables our plant operations, IT, maintenance staff to monitor our facilities to ensure we're meeting our production and quality goals. There are many data sources and systems that feed into the application in order to provide a holistic view of our plant operations. Let's take a closer look. So I've navigated to the, let me get full screen on this, to the PTC ThingWorx main page. I've got my 2 lines running here. You can see the configurations of both. I'm going to navigate to the mixer. And you can see we've already incorporated the power consumption prediction that we saw Jonathan provide. We've got vibration. That looks like it's addressed as well. And if I kind of move over to the packaging line, you can see that even our device health is looking good as well. So Ted, I think everything's looking pretty good.
Andrew, why is this packaging machine yellow then?
Hey, you're pretty observant. You must have had some great, slightly older mentors in your career.
Good mentors are good.
Good question, Ted. Good question. So let's take a deeper look on that, because that is concerning. And a warning, the yellow is a warning indicator. So again, I'm going to click on packaging, and I'm going to drill into the packaging machine here to get some deeper looks at what's going on. So data and system screens can be mashed together to provide a common interface specific to the packaging machine. On the left, we have links that takes us to various aspects of the machine. And on the right, we really have the display or the report and the analytics. So at the top of the page, kind of in this area here, you see some basic high-level overviews of what's going on. This is more the ThingWorx platform showing us things like model number, serial number, and basic things like OEE and mean time to failure and repair and so forth. At the bottom, we've integrated in our FactoryTalk Analytics platform. This is a storyboard. Thanks. I was going to say click, but I didn't. So here we have our storyboard. This is showing us data coming from various systems like our historian for time series data, production center for MES data, really giving us the context that we're looking for to do some deep level learning. Let me do one thing here to kind of show you what the capabilities are. So here I can see I've produced 76,000 pieces, making berry, green tea, raspberry, those that are different flavors. Let's say I'm only interested in the berry. I want to see what kind of issues or insights I can get by really slicing and dicing the data. So I'm going to say simply keep this. So in other words, only show me things related to when we were manufacturing the berry product. So now I'm filtered their entire report, all the analytics, any calculations that are done here are now updated so that I can see what's going on. But you know what? I'm a little distracted. So I really need to get back to my attention. At the top it does say, and this was to Ted's observation here, it does say that cart 12 has an issue. Now this is one of the many carts we use in our operations to transport packages around our facilities. So let's take a closer look. What I'm going to do is click on our prediction analysis link. And once again, I'm using kind of the ThingWorx navigation. And on the right-hand side, I'm drilling into an analytics data view display. This is dedicated to our machine learning algorithm, which is predicting when wear plates on each of the carts will fail. Now, although you're seeing only one of our MagnaMotion machines in our facilities, we have many and hundreds of carts. Although they don't need replacing often, the replacement procedure can cause unplanned downtime that we want to try and avoid. So we developed a machine learning algorithm to predict when excessive wear on each cart occurs.
Andrew, I was going to pretend I understood what you said about machine learning, but I don't. So could you back up and explain how you did that?
So let's start with the wear plates on each cart can deteriorate over time. And this is really, and therefore they need to be replaced. And this can happen at any time. So using the ThingWorx builder, we developed an algorithm that can predict when the cart's wear plates need to be replaced and have incorporated this into our system. So logic controllers are capturing various data points from each cart like distance traveled, acceleration, mass, and other data points. We use Analytics Edge to capture this data, do a first pass data cleanse, and we send it to a message queue such that Analytics Dataflow ML and DataView can use it for visualization. Dataflow ML now can orchestrate the data and calls the machine learning model, think of this as the digital twin, requesting a prediction. The result is then sent to DataView for visualization to the operations team, and this is exactly what you're seeing here. Now, considering the number of carts we have in our facilities, doing this manually would be a real pain. But we're not done. Like all good analytics, we need to take some action to close the loop. And what I'm going to do is create a work order for a maintenance person to replace the wear plate. I'm going to create a work order to replace the wear plate. This will prevent Mr. Thomas Rouble here from interfering or helping us in the future. Thank you, Mr. Rouble. All right. Thanks, Thomas. Let's move over to the work order. So I'm going to click on the work order link, and it's going to open our maintenance management system. This screen is filtered purely for the packaging machine, so I don't have to go anywhere else. I'm just looking at the package machine here. And I'm going to create a work order. So I'm going to click on the Create Work Order. And again, this is cart 12. So I'll say cart 12. I'm just going to simply say PM and say Create. Now, at the bottom, you'll see there's a job plan that's pre-configured for the maintenance staff. And there's a PDF that I've just opened here that shows the process if they need more details. Now, I can see in the future we will automate the creation of the work order to even get further efficiencies. So having access to data in an organized manner has really enabled us at Rage to truly get the benefits of a connected enterprise. Without having the building blocks of a rock-solid automation layer, pun intended, we would not have been able to develop the advanced analytics that were helping us squeeze every last ounce out of our equipment. And with all these benefits, I don't think I'll need as many of these energy drinks anymore, Ted. So back to you.
Thanks, Andrew. I hope this morning you've learned a little bit about how at Rage we're leveraging Rockwell Automation. We've shown you a lot. How we've created smarter machines by adding several layers of system-level analytics to our mixer. How Rockwell's simplifying analytics through integration into its architecture and by leveraging platforms like Microsoft Azure. How at Rage we have help when we really need it through Rockwell's managed services. How we're able to do enterprise analytics across our operations using tools like FactoryTalk Analytics and PTC's ThingWorx. This week at TechEd, I hope you have time to attend a session to learn more about FactoryTalk Analytics. They have a lot to show you with new products like FactoryTalk Analytics for Devices, DataView, Project Sherlock, and a lot more. Learn more about managed services, managed threat detection, predictive maintenance as a service, and more. Attend the What's New in IA session. A lot of capabilities have been added to the architecture over the last few years. We showed you the efficiencies we gain at Rage by using logic tag-based alarm. Learn about integrated network safety, the new workflows in Logix Designer, and lots more. Learn about the PanelView 5000 family. With its integration into Logix, an application can be created in a fraction of the time compared to competitive panels. Learn about the tools that we use at Rage to manage our automation systems, the benefits of managed switches, FactoryTalk Network Manager, thin client technology, Asset Center, the Product Compatibility and Download Center, Control Flash Plus. It's a lot. I know. That's why Rockwell invited you to TechEd for a whole week. Most of all, have fun. Network with your peers, and reach out to Thomas Rouble. There's no one here at TechEd who's a bigger advocate on your behalf. Thanks for joining us at TechEd, and have a great week.